Okay, so good evening everyone. I'm Niketa. I'm a PhD student from IIT Madras from the Department of Chemical Engineering, and I'm the TA for the course Basic Environmental Engineering and Pollution Control. So this is the week 5 of our online live sessions. So what we will do in these live sessions is I'll explain in brief certain topics from this week's course, and at the end of this lecture we will solve some questions and answers. So before we begin, I'd like to ask you if you have any questions from this week's lectures or from previous week's lectures. Okay, since there is no response, I'll proceed. So this is week 5. Okay. So in the previous lectures, we have seen about how to control air pollution. So there are mainly 3 types of air pollutants. The first one is gaseous pollutants or gases. Examples include sulfur dioxide, carbon monoxide, oxides of nitrogen, and so on. The second one is particulates. So majorly there are PM10 and PM2.5, and it's actually a combination of these two which is usually present. So we will see how to control each of these types of pollutants. So for particulates are nothing but solid particles which are suspended in air and which flow along with the wind. So how do we separate them? First option is by using gravity settlers. I'll explain in detail about each of these, but first we'll list them out. And the second one is electrostatic precipitators. And then there are filters, especially fabric filters. And then cyclone separators. And for gaseous pollutants, you can have wet absorption, and dry absorption. But if we have a mix of both particulates and gases, then what do? We can use wet scrubbers. We look at each of these in details. So first, gravity settlers. So in a gravity settler, as the name suggests, we use gravity to separate the particles from air. So because these particles are heavier than air, they easily settle down. But for that to happen, you need to provide a space where these particles can settle down and where the velocity of the wind is not too high. So, can you tell me why the velocity of wind matters here? Why does velocity of wind matter?
Because if velocity of wind is higher, the gravity settlers won't work.
Why won't it work?
Because gravity settlers it it needs time to settle.
But my question is, how does the velocity of the wind affect that? Okay, so when you have a particulate or a particle, so and it is being carried by the wind, so what happens? It tends to flow along the direction of the wind. So it tends to get carried away from this point to this point. And when there is no, when there is no wind or when the wind velocity is very less, there are okay. So what will happen if there is no wind or if the wind velocity is less? It tends to come down. So instead of going along with the direction of the wind, it will tend to settle down.
Yes, ma'am.
So there are two kinds of forces acting on the particle here. So the first one is the horizontal velocity of, force of the wind, and the second one is the force of gravity.
Gravitational force.
So when you have forces in two perpendicular directions, we usually take the resultant. So this is the resultant force, and similarly, the same thing happens for the velocity also. So if you have a particle which is flowing along with the wind, the velocity of the wind is v, and then what happens? But the particle if the wind velocity is not so high, so the particle is not able to be fully suspended and it is not flowing along with the direction of the wind. It is like it is going off track and it is coming down. So the velocity at which it tends to come down is its terminal velocity or Vp. So we'll see what is terminal velocity a little later. So again, resolving between these two velocities, we have the resultant velocity, which is Vr. This is the same principle that happens in the gravity settler. So it's a gravity settler is basically a chamber like this. So this is the inlet, and then the area suddenly expands. By area, I mean the cross sectional area. So the cross sectional area of the middle portion is larger. Can you tell me why the area has increased? Why do we need higher area in the middle than the entry and exit?
Settling to make it settle down.
Yeah. How?
I mean, flow is coming from inlet with some pressure, and substances will be settled down, and then it will go from outside.
Okay, so there is this formula for flow rate according to Darcy's law. So Q equals velocity into area. So that means velocity is flow rate divided by area. So Q is the flow rate here, and A is the cross sectional area. So when you increase the cross sectional area, so since velocity and cross sectional area are inversely proportional, so when we increase the area, the velocity will reduce. So what we are trying to do is we are trying to reduce the velocity of the wind that is entering this. So when it enters, it has a higher velocity, and then as it moves, its velocity becomes less. And what happens when the velocity is less? The force of gravity starts acting on the particle, and the particle starts moving downwards. So it won't be a direct downward movement because there are two forces acting on the particle already. The first one being the horizontal wind force, and then the vertical gravitational force. So it will
It will
tend.
slightly with form an angle.
So it will tend to move sidewards, and then after some time it will settle down somewhere here. And what happens once it settles down? So we have some dust collectors
We
here.
can collect.
So whatever particles are settled down can be collected and separated. But the one drawback of this method is that it can only be used for particles whose size is more than 50 micrometers. Can it be used for PM10 and PM2.5?
No, man.
Now, the time required for settling. So, like I said, once the particle enters, it won't settle down immediately. First, it will slow down, and based on its weight and the force of gravity acting on it, it will settle. It will take some time to settle down, and it will get collected later. So, this settling time, or the time required for settling time required by the particle to settle down, is your height of the chamber h divided by the settling velocity vt. Now settling velocity is like a constant velocity that the particle will reach once the gravitational force and the horizontal force get neutralized. So then that free falling velocity of the particle is called the terminal velocity or the settling velocity. So the settling velocity is given by the formula. CD is 24 by the Reynolds number. So substituting this, the terminal velocity becomes Now dp here is the particle size or the particle diameter. And μg is the viscosity of the particles, which is viscosity of the wind. So similar to that, we have the Howard settling chamber. And this is also a settling chamber, just like the gravity settler, but there's a slight difference in the design. So gravity settler was mostly horizontal, but this is a vertical chamber. So the design is like this. You have some separators. So when air flows, some particles tend to settle down. Like they tend to come to the based on their weight, they will tend to come to the settler surface and it will settle down here. Now, if the particle is heavier enough, it may tend to flow down and come to the last separator. And once the air is free of particles, it will come back and it will move out. So these are the two types of separators based on gravity. Now we have the electrostatic precipitator. So I did explain a little bit of this in the previous class. So basically it's like having two charged plates. So one is connected to the positive terminal, the other one is connected to the negative terminal. So one of them is positively charged and the other one is negatively charged. So when we allow a stream of particles to flow between these two plates, what happens is the negatively charged particles will get attracted to the surface of the positively charged plate and they'll stick to the surface. By sticking, I mean just electrochemical attraction. So, attraction due to electrochemical forces based on the charge and based on the charge of the particle, it will tend to attract towards the respective positive or negatively charged terminals. So usually dust particles are negatively charged, so it will get attracted to the positively charged plate. And once the charge is removed or it is disconnected, when the plates are disconnected from the current, what happens is these charged particles tend to settle down because there is no attraction for them anymore, so they'll just come and settle down. So there are two types of ESPs or electrostatic precipitators. The first one is the parallel plates, which we just talked about, and the second one is the wire and pipe. So a wire and pipe is a very simple design. It's like there is a pipe inside which we put a charged wire. So the wire is connected to the wire and the plate both are connected. Pipe both are connected to the power supply. The wire tends to be negatively charged and the plate will be positively charged. So what happens is when you make a stream of air containing particles enter into this, what happens is based on the charge of the particles, it will either tend to stick to the plate or it will tend to stick to the wire. So since the pipe is positively charged and dust particles are mostly negatively charged, so it will tend to stick to the surface of the inner walls of the pipe. So, and again, just like in the case of a parallel plate ESP, once the power is removed, the particles will not have any force of attraction to remain stuck on the surface of the plate or a pipe, and then these particles will fall down and they will be collected. Next is the fabric filter. So, a fabric filter, as the name says, it's a fabric made of very small pores, and these pores are used to let the air pass through and trap the particles. So, we will not have just one filter, so it will be like a cylindrical shape. So, and to this cylinder, we will attach the fabric. Like this. And we'll have series of such filters. So all of this will be housed in a container. So sometimes these containers which have these filters inside, here I've just shown two, but sometimes there could be around 10, 20, and these filters can also be huge. So then what happens is the container that houses these filters is also proportionally big. So in that case, it becomes like then we call it as a bag house filter. Because of the size of these filters, almost as big as a room or a house. So that is why these came to be known as bag house filters. So so what happened? I'll show you how it is. Here we have the inlet chamber where gas will enter. So once gas enters, it will tend to go up and enter the filter from the bottom. So once the air goes in, what will happen is automatically because of the gravity, most of the particles will get settled on the surface of the filter itself, whereas the air that is in will tend to move out. Because it is completely sealed from the top and there is just one inlet, So there is no other way for the air to go out except to move sidewards, because there are pores on the particle or the fabric. So these pores allow the passage of air, and when the air passes through these fabrics, it will let the particles stay on the fabric itself. So if the particles are smaller than the pore size of the fabric, then it will also come out. But mostly it retains the particles which are uh, small enough, like maybe 0.01 to 1 micrometer. So that is the size of the particles which are retained by these filters. So once we stop the air supply, then what happens is these filters tend to be loaded with these particles, and when the particle loading on the filters is heavy, then no more air can pass through, and it will create a pressure difference. So that will lead to like that means we cannot use the filter anymore unless we remove all the attached particles. So then what we do is we bring out these filters one by one, and then we uh, shake them. So if there are huge filters, then most of the time these containers itself are inbuilt with shakers. So they just shake the bag filters, and then they remove the attached particles, and then the dust is collected at the bottom. So here we have something like a dust collector. So here there is no gravity acting. In fact, it's just pressure. So we have a pump at the outlet. So that pump will create a vacuum force, because of which the air is traveling throughout the filter, and the particles get retained on the filter surface itself. So, like I said, the filter can be cleaned by shaking, and it can also be cleaned by reversing airflow. Or by using a pulse jet. So a pulse jet is a forced stream of air which is passed through the sides of the filter, so that the particles get detached from it and fall down. So even though it is a very highly efficient filter, so this is the particle size that is removed by this, which is quite good compared to gravity settlers, which was about more than 50 microns. But the backhouse filter or the fabric filter also has some disadvantages. The first one being that it is large and expensive. So, like I said before, when we have many of these filters, we need huge areas, and when we need huge amount of land, obviously the system becomes expensive. So it is large and expensive, and we also need proper maintenance. The second disadvantage is that there is this pressure drop issue. Like I said, when we have too many particles on the surface of the filter, unless we clean it, we cannot go further. So that is why there is this pressure drop happening. So when there is a pressure drop, no more air can enter the filter. And it cannot be used in moist environment, or places where the humidity is high, or when the air has a lot of water content. Can you tell me why? Why this filter cannot be used in a moist environment? So, in a moist environment, what will the air have? What will the air have in a moist environment, or air uh, that is high in humidity? Okay, so can you tell me what it means to have a high moisture content in air?
Humidity
Yeah, what is that? What does that indicate?
means air is having some water particles mixed with it.
Yeah, so the air could have water vapor or particles of water. So why is that a disadvantage for using a fabric filter? So what happens is when you have a fabric filter like this and air is moving through, so the air has water as well as dust particles. So when this air moves and when it flows out of the fabric filter, so both the particle as well as the water will get trapped on the filter itself. So when you have a lot of moisture, most of the pores will get blocked by the water particles itself. So there is very less pores left to be used for trapping the particulates. Most of them, if they are occupied by water, so that creates a non-usability. Like unless we evaporate the air or unless we do frequent shaking, we won't be able to use the filter for its entire capacity. So that is why we need to take care and ensure that if we are using fabric filters, then the air that is to be treated must be moisture free. Okay, next coming to cyclone separators. So a cyclone separator, like the name suggests, it creates a mini cyclone inside it. So we'll see how that happens. So cyclone separator is designed like this. This is the inlet, and then this is the chamber, and then we have the settling portion here. Then inside we have a smaller tube. I'll tell you why we have this. So when air comes, so this is the inlet. So when air enters, it goes this way, and once it enters, so the air enters at a high velocity. So when it enters at a high velocity, again here, if there are particles on the in the along with the wind, so have you all heard of this force called centrifugal force?
Yes, yes.
Yeah. What is the centrifugal force and how does it act?
revolving force, a kind of revolving force.
Revolving. No. So when you have a circular motion, or when a particle is in a circular motion, so the particle tends to move outwards. Okay, because that is because of the centrifugal force. So it tends to move out. So it is the same force that applies to particles here. So when air enters at a high velocity, suddenly it changes track. The air flows downwards, and because of gravitational force, the gravitational force acts downwards. So the gravitational force acts downwards, but because the air is already entering into a circular motion like this, or the wind is entering into a circular motion, so as the particle passes through these circles, there is centrifugal force acting on it, which makes the particle move sideways from its path. So if your particle is here, moving sideways means moving away from the circular path towards the container. So it's like the wind is acting like this, and your particles are moving sideways. So once they hit the wall of the container because of their sidewards movement, gravitational force acts on them, and then they are moved downwards. And what happens to the air inside? So the air inside, once the particles are it's completely free of air particles. So there is nothing that is holding back the air. So what happens is it kind of forms a reverse circular motion upwards. So I told you there is this tube here, right? That is the outlet through which the air will move out. So that's what happens in a cyclone separator. So it creates a mini cyclone because of which the centrifugal force acts on the particles, and the particles will tend to move sidewards and hit the wall of the container. And once they hit the wall, gravitational force acts on the particles and it moves downwards, so towards the settler. Okay, now summarizing all these methods for removing particulates from air. First, we saw gravity settlers. So gravity settlers, again, they require a large space, but the pressure loss is low. So going back. So this is the design. So unlike in fabric filters, there is no issue of pressure head loss or so. So the air wind velocity is only slowed down for a bit, and then once we reduce the cross-sectional area, again the velocity will increase and the air will come out. So the pressure loss is low. And then electrostatic precipitators. For electrostatic precipitators, the initial cost is high. But otherwise, it's a good method. So again, there are issues with electrostatic precipitators like corrosion, or because of sometimes acidic fumes may be present in the air that needs to be treated, so that will corrode the plates. And then fabric filters, they are good for particles, very fine particles up to 0.001 micrometer. So but the only problem is that if there is moisture, they cannot function well, and they are also prone to chemical attacks. So, like I said, if there is acidic fumes or chemicals that can chemicals that can damage the filters, then fabric filters cannot be used. And then cyclone separators, they are mostly inexpensive and require less maintenance. So, any questions so far? On any of these techniques? So, what if the air that needs to be treated has a combination of particulate pollutants and gaseous pollutants? So, like I said, we can use something called a wet scrubber if we have a combination of particulates and gaseous pollutants. So, in wet scrubbers, we will use liquid particles to remove particulates and dust. So, how this works is we will mostly sprinkle. We will have sprinklers attached to the ceiling from where the gas will flow. Imagine if the gas flows in this direction, and there are small particles on the gas along with the air. So these particles will be hit by water droplets, and once they get hit by water droplets that are coming from the sprinklers, they will become heavy, and they first of all they'll get stuck to the water droplet, and then their weight will increase, and because of that, what happens?
What's your question, ma'am?
Are you not listening? So I was asking if there are water particles, and if these dust particles get attached to the water particles, their weight will increase. What happens when weight increases?
It will create load on wet scrubber.
No, when you have water particles which are stuck with the particulate pollutants, the weight of the particulate pollutants tends to increase and it will fall down along with the water. So then it will be collected at the bottom as slurry. Now, why as slurry? Because it is a combination of solids and water. So it will be a mixture of both. So it is collected as a slurry. So the mechanism behind this is first there will be inertial impaction. And then there is interception. And then diffusion. So so we'll be looking at all these in detail. So inertial impaction is uh, when we have a particle along with the gas flowing in maybe in the horizontal direction like this. So what happens is because of inertia, the particle may be slightly heavy. So when the velocity of the wind reduces because of inertia, it will tend to displace from its path. So instead of going horizontal, it will tend to go downwards. So that is one way. And the second one is interception. Interception is when the particle of water tends to directly hit the dust particles. So once the water particle is traveling from this direction from the sprinkler. So we have a sprinkler like this. So from the sprinkler, the water particle is coming and it is hitting the dust directly. And then once it hits the dust, it tends to engulf the dust and then it will fall down and settle down. And the third is by diffusion. Diffusion is where your sprinkler is here. So there is water particles coming down. And if the particle of dust is quite small, it tends to move in a random motion. So as it moves in a random motion, it tends to diffuse and reach the water particle. So there are different types of scrubbers. The first one is the spray scrubber. So here we have a cylindrical chamber where we make the gas enter from the bottom here. So most of these designs, the gas enters from the bottom because it doesn't need any gravity, so it can go up. So that's why we make it enter from the bottom so that it will go up. So the gas containing the particles will tend to move up. And at the top, we have sprinklers. So here the sprinklers are spraying water droplets, and as the air moves up, then it will come in contact with the water particles and the dust particles will tend to stick to them. And then the air will move out and the dust along with the water particles will settle down. The second one or the second type is a packed bed and plate column. Here also the design is similar, the gas inlet is at the bottom.
Ma'am, I think in packed bed there is more space.
No space.
More space. I mean, it is like horizontal, little bit.
I don't get you. How do you say there is more space? So, packed bed is where we keep some particles and we pack them together. So, the advantage of having a packed bed is that most of the particles will get retained on the bed itself, on the particles, on the filling of the packed bed. So, then what happens? The air that is passed through the packed bed, it will tend to move up, and once it loses all the particles in the packed bed, it will come out. So, and then what we do, we provide an inlet for the water. So whatever solid particles are retained on the packed bed, they are washed out with water. And then there is also the plate column design. So here again the gas inlet is from downwards, and here we have some horizontal plates which are placed like this. So once the gas enters, it will tend to move in the direction where there are no plates. So again, because of inertial force, particles that are present on the along with the wind, these particles get stuck here. So once the particles are gone, the air will tend to move up in this direction, and the blaze will tend to collect these particles. So once they won't collect. Once the particles hit these plates, they come and fall down. The third one is a venturi scrubber. So a venturi scrubber is, has a venturi-like system. So the venturi is where the mouth of the venturi is wide, and then the neck is quite narrow, and then again there is a wider opening. So this tends to increase the flow rate of the air as the air passes through. So here the gas comes in here, and then we have the liquid inlet from here. So at the throat, the liquid particles that are entering just before the throat section. So because the area here is quite narrow, the velocity will be quite high. So there is acceleration of the water particles. So the gas that tends to come, it carries solid particles, and they also enter the throat, and then they get mixed with the water here, and then they come out at a very high speed. So once they come out at high speed, so the slurry, the particles along with the water, Those are the ones that are entering this slurry, entering the scrubber here. So this is the inlet of the scrubber. So there is water particles loaded with solid particles that are entering this, and then just like in a cyclone separator, there is cyclonic action forming here. And what happens here is whatever particles along with the slurry are there, they tend to fall down because of gravity. And whatever air was flowing in, it will flow along with these particles and it will enter into this scrubber unit, and here it will go out in a circular motion. So whatever particles were there, they get attached to water, and then they, because of the force of gravity, they come out. But the air will come from the top. So here the slurry is collected. So this was about gas and particulate pollutants together. So whatever gases that are coming out in all of these methods, they need to be treated again. So this, all these spray scrubbers, packed bed and plate column, these will separate the particulates alone, but still we have the gas to be treated. So we will see how to do that. So coming to gaseous pollutants. So the first method is by absorption. So can you tell me what's the difference between absorption and adsorption? What is the difference between adsorption and absorption?
For example, water soaking into a sponge can be a example of absorption.
But I'm asking the mechanism that is different in both. How is water soaking in a sponge different from adsorption? Okay, so adsorption is a bulk phenomenon. So what happens is, like you said, when we have a sponge and the water gets soaked through the sponge. So on the surface there is no water, but once you squeeze the sponge, the water comes out, which means the water was present inside or in the bulk of the sponge. So that is adsorption. So here the pollutant gets inside the absorbent, and the absorbent will retain the pollutant in the mass of the in its mass or in its bulk. So adsorption, on the other hand, is a surface phenomenon. So a good example will be like how you see activated carbon. So activated carbon will have a lot of pores on its surface. So these pores tend to attract pollutants, and then the pollutants tend to settle on its surfaces. But they won't move inwards; they only remain on the surface. So that's the difference between adsorption and absorption. So first, we will talk about absorption. So absorption can be three types: chemical absorption,
Can you give daily life example for adsorption?
daily life example. I just gave, right? Activated carbon you have
Adsorption.
for absorption. Yeah. So you know about activated carbon filters, right? In your water filter at home, there is activated carbon filter. Why is that used? So that's used for trapping volatile organic carbons in water. So most of these organic compounds, they are attracted towards the activated carbon surface, and they get absorbed on the surface and remain there. So unless once the pores get filled completely with the pollutant, we need to recharge the activated carbon. And by recharge, we mean the pores need to be cleaned from the pollutant. So the pollutant needs to be removed from the pores, and that is regeneration. So there are different types of absorption. The first one is chemical, and the second one is physical. And then we have physical and chemical absorption.
Your voice is not coming.
I just said physical and chemical absorption. Okay, and then talking about adsorption. So there are different types of adsorbents used. Some of them like silica gel or activated carbon. Even molecular sieve. Activated alumina. So all of these substances are porous in nature, so that helps in adsorption.
I think I have seen this silica gel used on rooftops for leakage. I think.
Okay. So then we use these for adsorbing gases. So coming to specific gaseous pollutants, first one is sulfur dioxide. So for removing sulfur dioxide using the dry method, we use activated carbon. And the second one is by wet scrubbing. So for wet scrubbing, like we already discussed previously, uh, once the gas comes out, so in all of these processes, once the gas comes out, so that is treated separately. So in the wet scrubber here, we use lime and limestone. So that will react with the sulfur dioxide and it will precipitate it. And then coming to oxides of nitrogen. So for controlling NOx, so NOx we usually get this from coal plants. So how can we avoid NOx generation from coal plants is by giving less oxygen or supplying less oxygen and combusting any fuel or coal at a low temperature. Sorry, at low or low oxygen concentration. And then we can minimize the residence time at peak temperature. So this gas is mainly produced at high temperature. So in order to avoid the production of this gas, we can reduce the peak temperature or reduce the residence time. At peak temperature. So what is the residence time here? Residence time is the time that the reactant, or in this case the fuel, will spend time inside the reactor. So if you have maybe coal in a coal plant, so we can reduce the temperature or we can reduce the time for which the coal is burnt at high temperatures. So both of these will effectively reduce the production of NOx gases. And then modifying the design conditions in such a way that NOx is not reduced at all. So this is for controlling NOx. Once you have NOx, then how do you treat? First one by absorption. So using a slurry of lime. So this will precipitate the NOx. And the second one is by absorption. Using activated carbon. Or silica gel. And the third one is by using catalytic converters. So catalytic what they do is they will reduce NOx into nitrogen gas. So these are basically catalysts that will catalyze the reduction reaction. So we'll see more about that. Catalytic reduction can be of two types. The first one is selective, meaning it only reacts with one kind of reactant. It will only catalyze one kind of reaction. So it will only catalyze nitrous oxide to, NO to nitrogen gas. Or it can be non-selective, which means both NO2 and NO can be converted to nitrogen gas. So these are the two types of catalytic converters. Now coming to carbon dioxide removal. For this we will use a chilled ammonia system. So what happens here is CO2 reacts with chilled ammonia and this will form ammonium carbonate. Or bicarbonate. So you just have to reduce the temperature of ammonia so that will react with CO2 and produce ammonium carbonate or bicarbonate. Okay, so that's it for today's lecture. So now we will move to questions and answers. So if you have any doubts, please let me know now. Okay, going by silence, I mean you don't have any questions. So first question is, which process is most efficient for removing particulate matter with size less than 1 micron? We just discussed this in today's class.
The answer is fabric filters.
Yeah, and what is the range?
Point 0.1 micrometer to 0.01.
Are you sure?
Yes.
It is 0.01 to 1 micrometer. So it will remove most of the particles which are greater than 0.01. So it is effective. Like more than 99% effective for particles greater than 0.01 micrometer. So next question is, which of the following adsorbents can be used for removing carbon dioxide? So the options are silica gel, activated carbon, and activated alumina. So what will be the correct answer?
Activated carbon.
Yeah. So activated carbon is mostly used for pollutants like methane or carbon dioxide, whereas silica gel is mostly used for C2H6 or some other heavier hydrocarbons. Activated alumina, on the other hand, is used for water, whereas molecular sieve is used for methane, carbon monoxide, nitrogen, and water. Third one, so the question is, which of the following methods use inertial impaction for removing particles in air? So the options are gravity settlers, electrostatic precipitators, fabric filters, and cyclones.
Cyclones.
How is inertial impaction occurring in cyclones? Can you explain? What was the mechanism in cyclone separators?
Centrifugal force.
Yeah. Is there any way for inertial impaction? What is impaction, first of all? So if you have a surface, maybe a pole here. Now what happens is these uneven surfaces on the unevenness on the surface. What happens is when there is airflow in this direction, it will tend to impact on the particle. By impact, I mean like if there is a particle that is moving in this direction, this this projection, it will tend to attach to the particle. So that is inertial impaction. So because of inertial forces, when the flow is in this direction, so because of inertia, if the particle is slightly heavy and the airflow is also, the velocity is also low, what happens? The particle will tend to come downwards. So when that happens, it will tend to get attached to the uh, surface here. So that is because of impaction. So that creates an impact and the particle tends to attach to the surface. So in cyclone separators, we have circular motion and then we have the centrifugal force acting on the particles. So there is no room for inertial impaction there. But I want you to think and tell me where we have this. Where this could be possible. What about gravity settlers?
I think when you explain this inertial impaction, it was under cyclones, so that's why I said that.
It was not
But
under
I'm not
cyclones.
sure.
It is definitely not under cyclones. So, like I said, inertial impaction is where both inertia and impaction will happen at the same time. So, inertia is where if you have a particle flow, if you have wind flowing in a particular direction, as the wind velocity becomes low, because of the weight of the particle, inertial forces will not allow the particle to move uh, with the wind. So, because of inertia, it will tend to stay where it is and not move with the wind. So once it stays where it is and doesn't move with the wind, gravitational force starts acting on it, and because of that, it tends to move downwards. And when it moves downwards, if there is a surface here, so this surface tends to make the particle collide on it. Okay, that is impaction. So this is collision or impaction combined with inertial displacement. So that means, so that is the thing behind inertial impaction. So in cyclone separators, the mechanism is because of centrifugal force and gravitational force. Here it is because of inertial impaction. So here the surface will tend to impact on the particle. So that is how the particle comes in contact with the surface. So this is it used in gravity settlers? Is this mechanism useful in gravity settlers? Okay.
So
So
in
in
gravity
gravity
settlers,
settlers,
the
the
main
main
force
force
is
is
gravitational
gravitational
force,
force,
and
and
in
in
electrostatic
electrostatic precipitators, it is
electrostatic attraction.
electrostatic attraction.
Whereas on
Whereas
fabric
on fabric
filters,
filters,
there is
there is
impaction.
impaction.
Like
Like
I
I
said,
said,
the
the
particle
particle
will
will
come
come
and
and
it
it
will
will
collide
collide
on
on
the
the
surface
surface
and
and
it
it
will
will
stay
stay
there.
there.
So
So
it's
it's
not
not
going
going
to
to move horizontally, it's basically stuck. So that is what happens when there is initial impaction. So the correct answer is fabric filters. So the question is, which of the following methods is suitable for removing sticky, flammable, or highly corrosive particulate matters? First one is electrostatic precipitators, then bag filters,
first
first
option
option is
is
ESP,
ESP,
second
second
one
one
bag
bag
filter,
filter,
and
and
the
the
third
third
one
one
is
is
a
a
Venturi
Venturi
scrubber,
scrubber,
and
and
fourth
fourth
one
one
is
is
by
by
absorption.
absorption.
So
So
can
can
you
you
tell
tell
me
me
which
which
is
is
the
the
correct
correct
answer?
answer?
And why? Okay, so we'll go one by one. So we saw what is electrostatic precipitator. Is it suitable for removing corrosive particulate matters?
ESPs can only work for like non-sticky particulates. I think that cannot be a answer.
Yeah. And what about bag filters?
Not sure, ma'am.
So we just discussed, right? So bag filters, if they have corrosive particles or corrosive pollutants passing through them, then what happens? They will tend to form a hole. So that means it won't be effective. Or if it is a sticky particle, then it will stick there and it will block the pores. So then removal will not be possible. The third one is Venturi scrubber, and the fourth one is absorption. So absorption, I don't think it is a good method for removing sticky or flammable or corrosive particulate matter.
I
It is
think the fourth
suited
option
for
is itself
gas.
wrong, ma'am.
Sorry.
The fourth option is wrong. I think
Yeah,
like
that's what I'm saying. That's what I'm saying. Why? So it is because absorption is mostly used for gases and not particulates. So
But
that
you have
means,
written absorption.
yeah, I said absorption, AB. I've written it correctly.
But the option is actually adsorption. AD.
How do you know?
Because it sounds like more correct.
The option is absorption. So both adsorption and absorption are used for gases and not particulate matter. So that rules out the fourth option. ESP can corrode and bag filters can get blocked. So that leaves us with Venturi scrubbers. So if you have some pollutants which are flammable, sticky, which are highly corrosive, then Venturi scrubbers are a better option. So with that, we come to the end of today's class. If you have questions, let me know, or we can end the session.
I haven't watched week 5 sessions on YouTube. So will I be able to do assignment 5 based on your session?
It's better to watch all the video lectures because that's the basis for your assignment questions. So this live session is just a follow up. It's more like a Q&A session. Whatever classes, I mean, whatever video lectures are there from each of the weeks, by the end of that, the live session will happen. So that if you have any doubts after watching those video lectures, you can ask me. So that is the objective of this live session. So if you have not watched it already, go and watch them. Ideally, you should have watched it before coming for the live session class. So that if you had any doubts, you could have asked me.
No, man.
Okay. So we will end the session. See you in the next class.